Dear students, we were working out problems on maxima minima in the earlier session. In this session also, I want to work out some more statement problems. Now the first problem is, first read the statement correctly, understand what is given, what has to be proved. Okay. Show that the right circular cylinder of a given surface area. When I use the word given, it has to be understood that the surface area is given and it is a constant. So wherever we make some notation for that one, wherever we use that notation while differentiating, you have to remember that it is a constant. Next, given surface area and maximum volume. So a cylinder has been given to us whose surface area is a constant, and when it attains a maximum volume, and maximum volume means when it attains the maximum volume, you have to prove that the height is equal to the diameter of the base. That means that if you take the radius to be r, h to be height, h should be shown that equal to 2r. Under what condition? When the volume is maximum. So this is what you have to understand. See, such that means maximum value when you see that the volume is maximum, this will happen. You have to show that h is equal to 2r. If you take h and r to be the height and the radius respectively. Now the surface area. Surface area means we are considering here a cylinder, isn't it? So cylinder means it would be like this. This is the cylinder. Now surface area means, see, it has got a, this surface, suppose you cut it open. If you cut it open, no, it takes the shape of like this, isn't it? It takes the shape of a rectangle. What is the area of the rectangle? The length into breadth. Breadth means it is nothing but the height here. The length means when it is in the circular form, it becomes the circumference. Suppose you take the radius to be r here and h to be the height here. So width becomes the h here. The radius would be the circumference of that one. It is nothing but 2 pi r. So 2 pi r into h is the radius, is the surface area of the curved surface. So the area of the curved surface would be 2 pi r into h. Now, the area of the top and the bottom, when you take the total surface area, see, top is also in the form of a circle as well as the bottom, and the radius is r, means it is a circle, means pi r square and pi r square, that is 2 pi r square. So that is a total area of the top and the bottom. And then the curved surface has the area 2 pi r. So the total, that is the surface area, means 2 pi r plus 2 pi r h plus 2 pi r square. So that is the total surface area. It is given. Given means you take your surface area, you can denote it whatever way you want. But remember, whenever you differentiate, think that it is a constant. Now here let me take the radius and the height is here like this. Okay. Now join this one. Now this is the height and this is the radius of the base, and you can take this. This is how we have to write. The height is the height of the cylinder. I am taking it as h here, and the radius of the base is taken to be r. So of course this considering the triangle is not necessary here. This is how it would be. Okay, this is the height. From here you can write in the dotted lines early. This is the h height and this is the r. So first always whatever you write here, first you have to explain that one. Of course here without figure also you can solve the problem here. Simply just to show how it is considered, I am drawn the figure here. Now let me make the notations here. Let r be the radius. This is how you have to write whatever notation. Though these are all standard notations, better you mention that in the statement here. Let r be the radius, h be the height, and v be the volume, and s be the surface area. S be the surface area of the cylinder. So first statement is like, let r be the radius, h be the height, v be the volume and s be the surface area, or you can take capital A also as the surface area of the cylinder. Now let me write about the surface area. See, we know that the surface area S would be equal to the area of the curved surface plus area of the top and the bottom. S is equal to 2 pi r h plus 2 pi r square. Take it as the result 1. Now, here, see here you observe h and r, both of them are variables here. Okay. Now, let us eliminate any one of them. Otherwise, no, if there are two variables, how do you differentiate? There has to be only one variable. So, you can write like s minus 2 pi r is equal to 2 pi r h, or h can be written as s minus 2 pi r square divided by 2 pi r, or h can be written as afterwards we can write, let it be like this, h is equal to s minus 2 pi r square over 2 pi r, or you can split and write also, no problem here. Okay. Now, let us come to the volume. This is given, if you want you can write inside the bracket for your reference. S is given means it is a constant. It is only for you to remember I am writing here. So, S is given means it is a constant. So, whenever you do the differentiation, remember treat that as a constant. So, H is equal to S minus 2 pi r square divided by 2 pi r. Now, what is the volume of a cylinder here? We know that the volume of a cylinder is pi r square h. You observe both r and h are variable. So, we have to eliminate any one of them. In this one, because the s is the sum of these two, it is better to eliminate h here because we are getting an expression for h here. So, this would be pi r square into, right, what is h here? S minus 2 pi r square divided by 2 pi r. Okay. Now, let me simplify this one. Here, multiply both the terms by pi r square. See, 1 pi you can directly cancel, 1 r also you can cancel. So, what is remaining now? V would be equal to s into r divided by 2. First term, s into r divided by 2. Next is r is there, r into one r has been cancelled, another r is there. Now, when you split it like this, it is r into 2 pi r square, that is minus 2 pi r cube divided by 2. So, even this 2 also can be cancelled, isn't it? So, another pi is remaining, 1 pi has been cancelled, 1 r we have cancelled, r is remaining, r into s by 2. Now, r into minus 2 pi r square divided by 2. So, that 2 is cancelled. So, we are having here pi into r square into r, that would be r cube. Therefore, we can write V is equal to s into r by 2 minus it is pi r cube. It is pi r cube. Now, just look here, we are having only one variable r. S is a constant, h has been eliminated. Therefore, we can differentiate with respect to r, or you can write v dash also. You can write v dash also. It is dv by dr equal to, remember that is what I told you, wherever s is there, think that it is a constant. So, it is s into 1 by 2, you write it as s by 2, and this becomes 3 pi r square. Now, this is the first derivative. Now, go for the second derivative for the confirmation. D square v by dx r square is, this is constant, so it becomes 0, minus 3 into, this is 6 pi r, isn't it? When you differentiate r square, we get 2r, 6 pi r. Now, say 6 is a positive number, pi is a positive number and r being the radius can never be a negative number, it is a positive number. So, minus of this one means it is less than 0. What is the reason? Since r is a radius, being a radius it is always a positive quantity. So, the second derivative is negative. What does it imply? It implies that is the volume is maximum. You know that we use the second derivative only to confirm whether it is attaining a maximum value or a minimum value. So, we know that the volume that is attained is maximum. But what is that we have to prove ultimately? We have to show that the height is equal to the diameter, or diameter is twice the radius. So, our aim is to prove that this is what we have to prove. To prove that h is equal to 2r. This is what we have to prove now. Therefore, we have seen that the second derivative is used only to confirm whether it is attaining a maximum value or a minimum value. So, now we have seen that the volume is maximum because the second derivative is less than 0. It is a negative number. Now, let us move on to the first derivative. You know that the first derivative should be 0. Let dv by dr be equal to 0. That is, what is dv by dr? I have underlined that one. That is s by 2 minus 3 pi r square is equal to 0. Now, cross multiply. S by 2 is equal to 3 pi r square, or s would be equal to 6 pi r square. Now, let us see what is s here. Okay, s is, let me write the value of s here so that we can get the relation h is equal to 2r. What is s you write? S means it is 2 pi r h plus 2 pi r square, that is equal to 6 pi r square. I am replacing s by the one which you already denoted. Now, you observe here 2 pi r square can be taken to the right hand side, hence it becomes 2 pi r h is equal to 6 minus 2, that is 4 pi r square. Some cancellation we can do. 2 ones are 2 twos are, you can cancel. Pi can be cancelled. 1 r can be cancelled. What is remaining? H is remaining 2 and another r, that is 2 h is equal to 2r. So, that is what we wanted to prove. Therefore, you write the conclusion in sentence, that is the height is equal to the diameter of the base. When does it happen? When the volume is maximum. When the volume is maximum. So, this is how, because it is a statement problem, always make it a habit to write the answer in proper statement. Even if you have written in the beginning h is equal to 2r, it is better, it is a good practice to express or to write the answer in proper sentence for the statement problems. Now, let me move on to the next problem. Now, students, it is another statement problem. So, when the statement problem is given, you have to be a little bit careful, read it and understand the data correctly, and how we have to write the statement, how we have to draw the figure if it is needed for a particular problem. Now, read the problem here. A wire of length 28 meters is to be cut into 2 pieces. That means that I am cutting, there is a wire whose length is given to be 28 meters. It would be cut into 2 pieces. One of the pieces is to be made into a square and the other into a circle. So, there is a wire of having the length 28 meters. I am cutting it not equal here, I am cutting it to 2 parts. Let me take A, B, C. AB is one piece, BC is other piece. Okay. Next, one of the pieces is to be made into a square. I take this piece and convert that into a square. Because it is a wire, it can be bent like that, isn't it? Next one is into a square and the other into a circle. So this one I am considering the second piece and convert that into, I bend it in such a way that it takes the shape of a circle. First one, it takes the shape of a square. Okay. Now come to the next part. What do I want here? What should be the lengths of the pieces? So what we have to get, what is AB, what is BC? The length of AB, length of BC I want now. Under what condition? So that the combined area of the square and the circle is minimum. So when you take the areas of both the geometrical figures here, the sum of the area, when it attains a minimum value, under that condition you have to find out the lengths of both the pieces. Suppose I take this as x. The total is 28, so this becomes 28 minus x. So I have to get the length x as well as 28 minus x. Look here, let me consider the wire to be AC here. I have cut at the point B. So AB, I have taken, let x be the length of the first piece. That is how you have to start the sentence. Let x be the length of the first piece, and then the length of the second piece would be 28 minus x. You have to write all the sentences. Let x be the length of the first piece. Therefore, the length of the second piece is 28 minus x. So one I am converting it to a square, the other one I am converting into a circle. Now let me take L to be the side of the square and R to be the radius of the circle. Now see, this is a straight. When you bent, it has taken the form of a square here. Whether it is bent or straight, the length is same. That is, when you take the sum of all the four sides of the square here, that would be equal to x. But what is the sum of the four sides? It is nothing but the perimeter. When L is the side of the square, what is the perimeter? It becomes 4 times L. L added 4 times. That is equal to x. Isn't it? That is equal to x. Therefore, L can be written as x by 4. Why I am writing is, we are interested in knowing the length of x here. When x is known, 28 minus x can be calculated. Now, here L is a variable and R is a variable. So, when these two are there now, differentiation not possible. Therefore, we try to get only one variable so that with respect to that variable, we can do the differentiation. Now, see here the length, it is a straight wire. I have bent it to form a circle here. Again, the same argument, straight or bent, the length remains the same. So, what is the length of this one? That means it is nothing but the circumference. When R is the radius, now what is the circumference? 2 pi R. That is equal to 28 minus x. Isn't it? That is the length of the second piece here. So, 2 pi R equal to 28 minus x. I want R also. See, L has been written in terms of x. R also should be written in terms of x only. Therefore, R would be equal to 28 minus x divided by 2 pi. Look here. See, the same wire which was cut into two pieces has been converted into two different geometrical figures here. One is a square, the other is a circle. This I have taken L, the side, and R being the radius here. I have expressed both L and R in terms of x here, so that when you consider the combined area, the x is the variable with respect to which I can differentiate the function. Now, let us consider the A. Let A be the area, the combined area. Let A be the combined area. What is the area of a square? L into L, that is L square. Now, what is the area of a circle? You know that it is pi R square. Correct? See, A is the combined area. You have to write that one. Let A be the, all those things you have to write. The statement should be written. Let L be the side of the square, R be the radius of this one. Therefore, the perimeter 4L equal to x. Therefore, the circumference 2 pi R equal to 28 minus x. Hence, R would be this and L would be this. Next, let A be the combined area of the square and the circle. Therefore, A equal to L square, which is the area of a square, and pi R square is the area of the circle. Now, L and R you have to replace here. What is L here? L means it is x by 4 the whole square. What is pi right as it is r square, that means 28 minus x the whole square divided by you write together, it is 2 pi the whole square. 28 minus x divided by 2 pi the whole square. Let me simplify before I go for differentiation. So this becomes x square by 16 plus pi into square this one. It is 28 minus x the whole square divided by 4 pi square. So 1 pi can be cancelled. So what is remaining now? It is x square divided by 16 plus 28 minus x the whole square divided by 4 pi. Now we have to differentiate with respect to x. Now don't treat it as a quotient because these two are constants. Differentiate only the numerator part, write the denominator as it is. Therefore, with respect to x we differentiate dA by dx. X square becomes 2x, denominator remains the same. Same thing here, it is a composite function. 28 minus x the whole square, x square formula. So it is 2 into 28 minus x, but 28 minus x also should be differentiated, whose derivative is minus 1 divided by 4 times pi. So 2 ones are 2 eights are, 2 ones are 2 twos are, you can cancel, and plus of minus, it is minus. So let me write dA by dx equal to x divided by 8 minus of 28 minus x divided by 2 pi. Now this is the first derivative. Now let me go to the second derivative, because we have to confirm that the combined area is attaining a minimum value. For that now we need the second derivative. D square A by dx square, it is 1 by 8, isn't it? We are having 1 by 8, and then what is the other one? Minus of 28 minus x. If you differentiate, it becomes minus 1, 28 being a constant. Denominator remains the same. That is 1 by 8 minus of minus plus 1 by 2 pi. Look at this quantity, 1 by 8 plus 1 by 2 pi. Pi is a positive quantity and we are adding, so it is greater than 0. So what is the conclusion here? When the second derivative is greater than 0, you know that the, whatever may be the quantity, in this case it is it's a area, it is attaining a minimum value that has to be mentioned. So it is 0, therefore that implies that the area is minimum. It is attaining a minimum value. Always we use the second derivative for the confirmation. So it is confirmed that it is attaining a minimum value. But what has to be calculated? We want the value of x here, isn't it? So we are confirmed that it is attaining a minimum value. Therefore, let us equate the first derivative to 0. So equate the first derivative to 0. What is the first derivative? Let dA by dx be equal to 0. dA by dx, underline that one. It is x by 8 minus 28 minus x divided by 2 pi is equal to 0. So with the help of this one, I can get the value because we are confirmed that the area is minimum. Therefore, at that point, now the critical point, the first derivative must be 0. That is x by 8 equal to 28 minus x divided by 2 pi. Now you can cancel this one. 2 fours are. Now cross multiply. It is pi into x equal to 4 into 28, that is 112 minus 4x. Since we want x here, take x to the left hand side. Pi x plus 4x is equal to 112. Hence we have, taking out common factor x, pi plus 4 equal to 112. Hence, we have x is equal to 112 divided by pi plus 4. So, what is x here? It is the length of the first piece. So, we calculated the length of the first piece. Now, what do you want here now? We want the length of the second piece also. See, when x is the length of the first piece, what is the length of the second piece? It is 28 minus x. So, let us write the value of x in this one and write it like this. Therefore, you write that is the length of the first piece. That is the length of the first piece is 112 divided by pi plus 4 meters. Hence, the length of the second piece. Length of the second piece is equal to 28 minus x because the total length was 28 meters. Now 28, what is x? You write 112 divided by pi plus 4. Now it is addition, taking the LCM pi plus 4, 28 into pi plus 4. So 28 into pi, 28 pi, 28 into 4, it is 112 and this is minus 112. These two, they get cancelled. What is remaining? 28 pi divided by pi plus 4. So, the length of the first piece is 112 divided by pi plus 4. The length of the second piece is 28 pi divided by pi plus 4. So, how do you write the answer here? The lengths of the pieces, lengths of both the pieces is they are equal to, first one is 112 by pi plus 4 meters and the second one is 28 pi by pi plus 4 meters because it was given in terms of meters. Now, this is how you have to solve. So, whatever quantities have been given in the problem, first you write that one given. Then read the problem correctly, analyze what has to be calculated under what condition. So, the notations you can make of your own. Usually, we take A for area, V for volume, H for height. There is a common notations we are using. If any other notation you use, first you define that one, what exactly you are which letter you are using to denote what particular quantity. Then you can proceed to get the result. Now, we try another problem. Yes, dear students, we are moving on to the next problem. It is again a statement problem. Now, let me read the statement. Show that the semi-vertical angle of the cone of maximum volume and of given slant height is tan inverse of root of 2. See, they have already given the answer. You have to try to get that particular answer here. Now, I have taken a cone here, okay. Now, let us see the data here, which is having a maximum volume. We will find out afterwards. We will see whether we will have to verify whether it is attaining a maximum volume or not. But they have given that when it attains the maximum volume and of given slant height. I am repeatedly telling you, whenever we use the word given, it has to be understood that it is a constant. So, slant height. So, now here this is the cone, AB is the height of the cone and BC is the radius of the base and this AC is called as a slant height. It is given. So, denote it as S only. Now, semi-vertical angle, vertex means this point, semi means half of that one. The semi-vertical angle, denote this as say theta. So, our aim is to get the value of theta as answer is already given. You have to show that theta is equal to tan inverse of root of 2. So, when they given the answer tan inverse, it shows that we have to consider the tan ratio, tan function. So, I have to get tan theta to be root of 2, so that I can write theta to be equal to tan inverse of root of 2. First, how do you write? After writing the figure, first you have to explain. Let h be the height of the cone, let r be the radius of the cone, let the s given you can write, and you can write for your reference, it is a constant. Okay. Let h be the height, r be the radius, s be the slant height of the cone. Now, let v be the volume. Let v be the volume. Now, what is the volume of a cone? It is 1 by 3 pi r square h. For cylinder it is only pi r square h. For cone it is 1 by 3 pi r square h. Okay. Now let me write that one. It is we know that V is equal to 1 by 3 pi r square h. Now let me write it as 1. Look here, r and h, they are varying here. Only the condition is when it attains the maximum volume. So volume may, the radius may be bigger, height may be shorter, or height may be more, radius may be shorter. So they both of them are variable. Therefore, we have to try to eliminate any one of them so that we can, there will be only one variable left. With respect to that variable, we can go for differentiation. For that now we come to this one. We have to make use of the given, that is data, that is the slant height. Now look at the triangle ABC. What type of a triangle? It's a right angle triangle. So automatically we make use of the Pythagoras theorem, that is AB square plus BC square equal to AC square. What is AC square? It is S square equal to H square plus R square. Isn't it? See here either H or R, any one can be eliminated. We have to think a little bit here. In the formula we are having R square and H. See if you replace H here, root of something you will be getting, root of A square minus R square. So to avoid the two, look at this, we are already having R square. So it is better to eliminate R here. That means that R square can be written as S square minus H square. Okay. Now you take it as result 2. We will be using it afterwards. Now substitute for R square in the result 1. Therefore equation 1 or the result 1 becomes V is equal to 1 by 3 into pi into R square. How do you write R square? It is S square minus H square into that another H I am writing as it is. Now let me rewrite this and then we can easily differentiate. So V would be equal to pi by 3. Now multiply both these quantities by H which is outside. It is S square H minus H cube. Now you observe, remember S is a constant and H is the variable that is left out. So we can differentiate with respect to H, or you can write V dash also. V dash also. Simply I am writing this one so that you will be knowing with respect to which quantity we are differentiating. That is pi by 3 into, it is S square, where with respect to H we are doing. If it is with respect to X, now for X we write 1. So for H I am writing 1 and the other one is 3H square. This is the first derivative. We need it afterwards. So I am underlining this quantity. Next is differentiate for the second time to know whether it is attaining a maximum value or a minimum value. It is pi by 3 into S square being a constant is 0 minus 6H, or 3 ones are 3 twos are if you cancel, minus 2 pi H. See, look at this quantity. We do not know the value of H. One thing is you can equate it to 0, substitute the value of H here, then you will know it becomes a negative quantity. But even otherwise you can argue H is the height of the cone being always a positive quantity. Strictly speaking, we have to equate it to 0. We get the value of H, substitute here, then find out. Even otherwise, now you can argue H being the height of the cone here, it is always a positive quantity. Pi is a positive number, 2 is a positive number. So my negative of all these positive quantities will be always less than 0. So the second derivative less than 0 implies, what does it imply? The volume is maximum. See, just to get this information, just to get that volume is attaining a maximum value, we have to consider the second derivative. But what is our aim now? We have to get the value of theta here. That is important. So after confirming that it is attaining a maximum value, let me equate the first derivative to 0. What is the first derivative? dv by dh equal to 0 implies pi by 3 into s square minus 3h square equal to 0. Pi by 3 cannot be equal to 0 being a constant. S square equal to 3h square, or h square is s square by 3 Therefore, h is s by root of 3. So, we got the value of h here. H is s by root of 3. Now let me calculate the value of r. The reason is, look here, we are interested in finding the value of theta. You have to show that it is equal to tan inverse of root 2. That means that we have to take tan theta. How do you define tan theta? Opposite over the adjacent side. For this angle theta, r is the opposite side, h is the adjacent side. So, we have calculated h, isn't it? Therefore, we want to get the value of r also, so that when you take tan theta, you can show that it is equal to root of 2. Now, come to this relation, that is r square equal to s square minus h square. That is the second relation. From second relation, r square equal to s square minus h square. H square we have calculated already. That is s square minus s square by 3. So, taking the LCM here, it is 3 minus 1, 2, that is 2s square by 3, or r would be equal to s into root 2 divided by root of 3. Okay. So, we got the value of h as well as r. Now, you write from the triangle ABC, consider tan of theta, because the answer is given tan inverse. Otherwise, you could have taken any ratio, sin theta, cos theta, anything you could have taken, because s was already known to us. Because it is given in terms of tan, I am taking tan theta. Tan theta means it is r divided by h. What is r? S into root 2 by root 3. What is h here? S by root 3. S and s, root 3, they get cancelled. What is remaining? Only root 2 is remaining. That means that when tan theta is equal to root of 2, what does it imply? You have learnt about the inverse trigonometric function. Therefore, it is tan inverse of root of 2. So, this is how we have to find the value, or we have to get the semi-vertical angle in terms of the given quantity. That is, it was given that the volume is maximum. When the volume attains a maximum value, you have to show that the semi-vertical angle of this particular cone having a given slant height is equal to tan inverse of root of 2. Now, these are the problems under this maxima minima I have worked out. Now, in the same topic, maxima minima, there is one more type of maximum minimum value. Here we were discussing about the local maximum, local minimum values, but there is another another type of maximum value which is called as the absolute maximum and absolute minimum value, that I will be taking up in the next session. Thank you.